Have you ever wondered how all the devices in your home or office communicate so seamlessly? Welcome to the world of local area networks, or LANs. These networks are the unsung heroes that connect multiple devices, like computers, printers, and servers, within a confined space such as a building or campus. They play a crucial role in our daily interactions, facilitating everything from sending a document to a printer to streaming a video or accessing the internet. Let's dive into the fascinating protocols that make all this possible. Now, meet Ethernet, the undisputed champion of LAN technologies. Imagine a world where every office, every school, and every home is interconnected not just by roads and power lines, but by an intricate web of data cables. That's the world Ethernet has built. Governed by the IEEE 802.3 standard, Ethernet has set the rules of engagement for how devices communicate over these networks. Let's delve into the various topologies Ethernet embraces. Whether it's the bus topology, where each device is connected to a single communication line, the star topology, where each device is linked to a central hub, or the ring topology, where devices are connected in a closed loop, Ethernet adapts seamlessly. Each topology has its own charm, catering to different network needs and scales. Now to the magic happening at the MAC layer. Ethernet uses a method known as Carrier Sense Multiple Access with Collision Detection, or CSMACD. This technique is rather like polite conversation at a busy dinner party. Before a device transmits data, it listens to ensure no one else is speaking. If the coast is clear, it goes ahead. But if two devices speak at once, a collision occurs. They then pause, wait for a random period, and attempt to speak again. This method drastically reduces data traffic collisions, ensuring smooth communication. Data in Ethernet is wrapped up in structures called frames. These frames are like letters with a clear address written on them, detailing where they're from and where they're going. Inside these frames, you'll find the source and destination MAC addresses, among other control information, ensuring the data reaches the right device. Over the years, Ethernet hasn't just stuck around, it has evolved. From the humble beginnings of 10 Mbps to the dizzying heights of over 10 Gbps, Ethernet speeds have soared, matching the pace of our digital demands. With such versatility and speed, it's no wonder Ethernet dominates the LAN landscape. Now, let's explore Token Ring, a once popular network protocol that played a crucial role in the evolution of LANs. Token Ring, defined under the IEEE 802.5 standard, was a notable player in the realm of network protocols during its prime. This protocol was distinct for its structured approach to managing network traffic and data transmission. At the heart of Token Ring was a commitment to order and efficiency, elements that were crucial in the era of burgeoning computer networks. The physical layout of Token Ring networks was based on a ring topology. In this setup, each device connected directly to two others, forming a continuous loop. This structure was pivotal because it influenced how data traveled across the network. Unlike chaotic and collision-prone environments, the ring topology provided a clear pathway for data packets, with each packet making a full loop until reaching its destination. The magic of Token Ring lay in its media access control, or MAC layer, which utilized a token passing mechanism. In this system, a special token frame circulated around the network. Possession of this token was the network's green light, signaling permission to transmit data. This method was particularly effective in preventing data collisions, a common challenge in network communications, ensuring a smoother flow of information. Data in Token Ring was transmitted using frames, similar to those in Ethernet, yet tailored to fit the ring's unique needs. These frames included essential information such as source and destination MAC addresses. The structured passage of these frames from one device to the next underpinned the network's reliability and orderliness. Initially, Token Ring networks operated at speeds of 4 megabits per second, a respectable rate at the time. As technology advanced, so did Token Ring, evolving to support speeds up to 16 megabits per second. However, despite these developments, the dawn of faster and more flexible technologies eventually saw Token Ring overshadowed by alternatives like Ethernet. Though now overshadowed by Ethernet, Token Ring's legacy in network technology is undeniable. Why did Ethernet become the preferred choice over Token Ring? Let's find out. In the realm of local area networks, Ethernet and Token Ring were once like two gladiators in the arena, each with its own strengths and strategies. However, as the dust settled, it was Ethernet that emerged as the victor, largely due to its simplicity, cost-effectiveness, and scalability. Firstly, the setup and maintenance of Ethernet networks are remarkably straightforward compared to Token Ring. Ethernet's flexibility in terms of network topologies, be it bus, star, or ring, makes it adaptable to various environments. This simplicity extends to its troubleshooting and expansion capabilities. Moreover, the cost of implementing Ethernet is significantly lower than that of Token Ring. Ethernet devices and cables are generally more affordable, and the widespread adoption of Ethernet technology has further driven down prices due to economies of scale. Token Ring components, on the other hand, were typically more expensive and harder to source, which inevitably added to the overall network costs. Scalability is another critical factor where Ethernet shines. With speeds evolving from 10 megabits per second to fast Ethernet at 100 megabits per second, and all the way up to 10 gigabit Ethernet and beyond, Ethernet networks can easily be scaled to meet growing data demands. Token Ring, while it started at 4 megabits per second and was later upgraded to support higher speeds, struggled to keep pace with Ethernet's rapid developments. The technological advancements and widespread industry support for Ethernet have also played a significant role in its dominance. Innovations such as Carrier Sense Multiple Access with Collision Detection, CSMACD, enabled more efficient and reliable data transmission, which was crucial as network traffic increased. Token Ring's decline was further hastened by its inherent complexity and higher operational costs. As networks grew and data traffic volumes increased, the limitations of the Token Ring protocol became more apparent, leading many to switch to the more flexible and cost-effective Ethernet. As we can see, practicality often leads the way in technology adoption. Ethernet's ability to evolve with the changing landscape of network demands, coupled with its simplicity and cost efficiency, clearly highlights why it became the preferred choice in the battle of network protocols. To sum up our journey through the veins of local area networks, let's recall the significant strides made by Ethernet and Token Ring. Ethernet, with its robust protocol and versatile topologies, has proven indispensable in modern networking. Its carrier sense, multiple access with collision detection mechanism ensures efficient data transmission amidst bustling network traffic. On the other hand, Token Ring, with its orderly token passing system, although less prevalent today, set foundational standards in network communication. Ethernet's triumph stems from its simplicity, speed, and adaptability, making it the backbone of countless networks worldwide. Next time you stream a video or send an email, remember the silent, speedy work of Ethernet making it all happen. Thank you for joining me on this exploration of local area networks.